an artist's depiction of Kyongjuji, a species of theropod dinosaur that lived 160 million years ago in what's now northeastern China. Illustration by Velazar Simeonovsky. The Field Museum talk about a fabulous find. A new dinosaur discovered in China had feathers that may have glittered with the colors of the rainbow. Based on its stunningly preserved remains, scientists say the dinosaur's head and chest seem to have been covered with iridescent feathers akin to those on modern hummingbirds. The flashy display may have provided a social UALQ, like modern peacock tails. The dinosaur also has a bird-like body, including the sorts of feathers required for flight, but it has a crested head that more closely resembles that of a velociraptor. Dinosaurs 101. They ruled the Earth for more than 160 million years, but much about how dinosaurs lived and died remains a mystery. See what we know and don't know about the age of dinos. Given these traits, the ancient animal has been named Kyongjuji, Mandarin for rainbow with a big crest, the team reports today in the journal Nature Communications. Kyong lived in forests and may have glided from tree to tree, preying on small mammals and lizards, says study co-author Xing Zhu, a paleontologist at the Chinese Academy of Sciences. In life, the duck-sized carnivore would have weighed roughly a pound. I was shocked by its beautifully preserved feathers, even though I had seen many feathered dinosaur fossils previously, adds Zhu. The slab containing Kyongjuji. Exceptional conditions allowed the dinosaur's feathers to fossilize along with its bones. Photographed by the Field Museum. Birds, the last living dinosaurs, use feathers today for flight, but feathers also help birds woo potential mates or jockey for social status. Dinosaur fossils suggest that feathers originally evolved for display, only later taking on the traits needed for flight. Learn more about how feathers evolved. Like modern and ancient birds, dinosaurs likely had color vision and took advantage of it with striking, feathery displays. In exceptional cases, scientists can reveal dinosaur feathers' original colors by finding vestiges of pigment sacs called melanosomes within fossilized plumes. See the body coloration of the feathered dinosaur Anchiornis. Yang Zhan, a local farmer, found the Kyong fossil in northeastern China's Hebei province. In February 2014, the Paleontological Museum of Liaoning acquired the fossil from Zhan. When scientists led by Dong Yuhu, a paleontologist at China's Shenyang Normal University, examined the fossil, they found that its well-preserved remnants contained traces of pigment in its feathers. The team sampled 66 sites across the fossil, comparing the melanosomes they saw with melanosomes from modern bird feathers. On Kyong's head, chest, and parts of its tail, the researchers saw melanosomes that were long, flat, and organized into sheets. These patterns most closely match the melanosomes in the iridescent throat feathers of hummingbirds. In hummingbirds, similar structures split light like a prism, creating a metallic sheen that changes color with the viewing angle. The team couldn't reconstruct the dinosaur feathers' exact colors, but they suspect that the observed pigments gave Kyong a rainbow glimmer. See hummingbirds fly, shake, drink in amazing slow motion. They move so fast that human eyes see only a hovering spot of color, a blur of wings. But when frozen in time by high-speed cameras, hummingbirds yield their secrets. Paleontologists have seen this sparkle in dinosaurs before. In 2012, scientists found evidence that the feathered dinosaur Microraptor glinted blue in the sun like modern crows and grackles. Unlike Kyong, though, Microraptor was iridescent all over, and it is much younger. Microraptor lived 40 million years after Kyong. When we put these data on the evolutionary tree, we recognize two different ways of creating iridescent color in small raptor dinosaurs before the origin of birds, says Julia Clark, a paleontologist at the University of Texas at Austin who co-authored the Kyong and Microraptor studies. Kyong may not have used just its feathers for showing off, notes University of Edinburgh paleontologist Steve Broussat, who reviewed the study before publication. Its plumage was a shiny rainbow of iridescent colors, but it didn't stop there, he says. It also had a funky crest of bone sticking up in front of its eyes, which was probably a display structure as well. The skull of Kyongjuji. Photographed by the Field Museum. In addition, Zhu says that Kyong's frond-like tail has asymmetrical feathers, and their short, stiff leading edges would have borne the aerodynamic load of flight. Kyong is now the oldest known animal to have this key adaptation. The iconic bird-like dinosaur Archaeopteryx also has asymmetrical feathers, but it lived 10 million years later. With Kyong, who knows what the functions of this large, wide tail were, says National Geographic explorer Ryan Carney, a University of South Florida biologist who studies Archaeopteryx. Perhaps it was held up as a dark background to provide contrast against the iridescent head during displays. Clark, an expert on the origin of birds, says that researchers also can't yet be sure how Kyong used its iridescent feathers, or whether males or females of the species had different plumage. For that, paleontologists can only hope for further study of the new fossil, and perhaps even more bones from Kyong and other feathered dinosaurs. The more feathered dinosaurs we find, the more we learn just how bird-like they were, adds Broussat. We have to think of these animals as birds. If we were alive back then, that's what we would have considered them.